All right, so let's take a look at a couple more. Here we have absolute value. So we're looking at the area. Remember, what we're going to do is we want to find the area by using a geometric formula. So if I can draw this out, it's going to be easier to see. And if we look at a question like number 8 here, we have our absolute value. Absolute value is easy to graph. We're going to go from 0 to 4. We have a vertex at 3. And we know what absolute value looks like. It looks like a check mark. There it is. So if you notice, what we wind up with is two triangles. And I know the area formula for a triangle, 1/2 base times height. So we have to find their heights, and that's easy. At 0, this is going to have a height of 3, and at 4, this side is going to have a height of 1. And I can get their base. Here's 3, here the base is 1. So if I want to find them, I'm going to add them up. 1/2. The first base is 3 by 3, and the second triangle is going to be 1/2, 1 by 1. I don't know why I have that there. Let me get rid of that. There we go. Don't simplify, but if you want to, you can. This is 9/2 plus 1/2, which is just 5. So that area there would be 5. Number 9 gets a little bit trickier for us. Let's graph this one. If we were to graph our function here, y equals the absolute value of x minus 3. Let's take a look here at what this looks like. My y-intercept here is negative 3. And there is my function. We only want the area between 0 and 3. But if you notice, we are below the x-axis. And we talked yesterday and the day before, if we are below the x-axis, we say the area is negative. So if I want to find the area for this one, it's still going to be a triangle. Base is 3, height is 3. But we're going to make it negative. 1/2 the triangle, base is 3, height is 3. Again, because this is below the x-axis, we are saying that in this case, we're saying that it is decreasing. We're going to find out later on that this is a derivative. And remember, if we're below the x-axis, we say the function is decreasing. Same thing here. We are saying that the values are decreasing. That becomes later on for us, way later on. So we get a negative 9/2. Now again, area really can't be negative. The negative is more directional for us. It's just telling us that, hey, this is below an x-axis, or we're heading, in terms of physics, we're heading to the left. All right, very easy to do. So let's talk about even and odd functions. So an even and odd function, you talked about these last year in pre-cal. An odd function is a function that, as we say, is symmetric about the origin. That means on both sides of the x-axis. One's going to be above. So if we're looking at it right here, and here we have one, symmetric about a point or the origin. If we look at the graph right here, we have an odd function, kind of like a cube. This looks like maybe x to the 1/3, maybe. So notice, on the right side, we're above the x-axis. And that's telling us that this is a positive area. On the left side, notice, we're below the x-axis. Now, according to our rule, if we're below, we have a negative area. Again, area really can't be negative. We're just saying it's more directional. It's just below. It's just telling us that we're below the x-axis. Our function's below. So, if it's symmetric, that means these two have to be the same, but opposite signs. So if I were to write this as an area, my positive part my little s down here would be really a negative s plus this area s. And notice, we're going to get 0. They're going to cancel out. We saw this in yesterday's notes when we did 0 to pi of sine of 2 pi of 2x dx. We found that that area was actually 0, and again, the reason for that is because between 0 and pi, this is what sine of 2x looks like. those areas are the same, so they cancel each other out. So if we know a function is odd, we know it's going to become 0. But what if it's an even function, like a parabola, like y equals x squared? Well, even functions are symmetric about a line, most likely the y-axis. And that's what we have here. Notice, between 0 and a, we have an area of S. And we're above the x-axis, so again, this is a positive area. Over here, we are still above the x-axis, so again, it's a positive area. But notice, it's symmetric, so they're the same. So what's going to happen to these two? Well, we would just add them up, so we get 2s. So we know if the function is even, it's just going to double that area. So let's try one. Ready? There's definitely an error here. Let's scratch this out. Oops. So let's say 0 to 2 of this function, 10x to the 4th, is 32 over 5. Well, I know that this is an even function. So the question, so if I'm going from 0 to 2, we're saying that this area here is 32 over 5. So if we go from negative 2 to 2, the area should also be 32 over 5. So it's going to double it and make it 64 over 5. That's a weird looking 5 right there. There we go. Now, what about problem like number 2? Well, let's do x cubed. Well, I know that this is an odd function. So what that's telling me is between 0 and negative 3 and 0, that should actually be negative right there. This is going to be a negative 81 over 4. And over here, so that's from negative 3 to 0. From 0 to 3, it's going to be positive 81 over 4. So what's going to happen to those? Well, if I add them up, they're going to cancel each other out. They're going to give me 0. So let's try number 3 here real quick. Let's say we go from 0 to a. The area from 0 to a of f of x is 7. So I can do that. So that's telling me if I go from 0 to a, and if I were to draw a box there, I know that that area is 7. Well, then they tell me if it's even, what would negative a to a be? So now I want to go from negative a to 0. Well, if it's even, it's going to be symmetric about this y-axis. It's also going to be 7, and we can double that and get 14. Well, what if it's odd? Well, again, from 0 to a, it's going to be positive 7. But from negative a to 0, we're going to be below because it's going to be odd. It's symmetric about that origin. But that area becomes negative 7 here because we're below the x-axis. And if we were to combine them, we add them up together, we would get 0 because negative 7 plus 7 is 0. Like 7 over 7 plus 7 over here is 14. Very easy to do. So there's some other properties that we have. Remember, this integral finds area. 1. If we are, excuse me, if we want to find the area from a to a, that area is going to be 0. Think about this. This is a rectangle. That's from a to a. Right? This has a width of 0, right? So if that has a width of 0, of course the area, therefore, would be 0 right there. This is an interesting rule right here. If we switch directions, if I'm going from A to B, and I go now from B to A, we just change our signs. It becomes opposite. So this one, we just say basically if you change your direction, change signs. We'll talk more about why this works later on. Over here, from A to B, this one right here just says we can split up an area. We did this. This is just we can split an area. And that's kind of what we did up here. If I want to find the area here, I went from negative a to 0, and then from 0 to a. I just add them up together. I can split any area that I want. Over here, we have what's called the constant multiply, where you can just factor out constant. This is just this. We can factor out a constant. And over here, same thing. We can add and subtract areas. We can add and subtract. Cannot spell subtract today. I don't know what's wrong. So we can add and subtract areas. That's all that one says. So let's try it. Let's try this using these little properties right here. For example, number 1, I want to find out what the area from 2 to 2 of x plus 5 is going to be. Well, if I notice, starting at 2 and I'm ending at 2, that area is just going to be 0. Over here, what if we want to go from 3 to, the area from 3 to 0 is 21 over 2. Well, what would the area from 0 to 3 be? Well, my rule said I'm just switching it. This is going to be the opposite of 3 to 0 of x plus 2. And if my answer there was 21 over 2, this is going to be negative 21 over 2. We just switched the directions. And our rule says if you switch directions, you switch your signs. For questions like number 3, this is always a fun one right here. If we let the area from 2 to 5 x to the 4th equals 40, from 2 to 5 of x dx is 7, 2 to 5 dx is just 3, and I want to evaluate what this is going to be. Well, I'm going to use these properties up here. I'm going to split them, and I can use these properties where I can rewrite my integral as addition, subtraction, and I can factor out any constants. For instance, this 3x to the 4th, I can write this as the area from 2 to 5 x to the 4th dx plus 3 from 2 to 5 x dx minus 2 from 2 to 5 dx. Basically, I can distribute the dx and the integrand. That's really what it's kind of telling. I can distribute those. So for the first one, x to the 4th, they tell me that was 40. X, they tell me the area from 2 to 5 is 7. And then from 2 to 5 for 3, that becomes a 3 there. I don't know what that is. I'm just going to leave it alone, honestly. There we go. And here's an AP question for you. Here they tell us the area of f of x from 1 to 10 is 4. From 10 to 3 is 7. And then from 1 to 3, they want to know what the area from 1 to 3 is. So I know the entire area, but these two are kind of split. So if I write this, I can say that the area from 1 to 10 f of x dx is equal to the area from 1 to 3 f of x dx plus the area from 3 to 7 f of x dx. Now we have to talk a little bit. This I already know. I know that that's 4. The area from 1 to 3, that's my question mark. That's what I want to know. Plus, but this one's a little bit trickier. Notice first of all, this should be from 3 to 10. I know we had some comments on the video on that one. That should be 3 to 10. But even better, notice we switched. We flipped directions. We flipped directions or switched directions. So what does that mean for us? Well, whoops, sorry. We flipped directions, which means we have to change our signs. So instead of this being a 7, this has become a negative 7. And then I can add them. 1 to 3 f of x dx. And if I add the 7 over there, that's just going to give us 11. So the answer is going to be D. All right, I hope you enjoy these videos. I will see you later. Bye-bye.